Hello everyone, welcome back. Today we'll be starting with this topic of resolution of vectors. Now what does this resolution of vector means is whenever I have a vector, let us say A, what I can do is I can split this vector into its component, and this process of splitting a vector into its component is nothing but resolution. Okay. Now let us say I have a vector A over here, and I split it into two parts. This is one component of A and this is another component of A. Okay, so this is vertical and this is horizontal, right? Now let us say this is the X component because it is along the X axis, and this is the Y component, so I'll denote it by AY because it is along Y axis. Okay, now what I can do is I can complete this parallelogram over here. Quadrilateral I am completing over here, and let us say this resultant is making an angle of theta with the horizontal axis. Now what we can do is by using parallelogram law of vectors, what we can do is we can write vector A is nothing but vector AX plus vector AY. Okay, so these are the two sides of the parallelogram meeting at this origin point, and their resultant is found out as capital A, right? Okay, now every vector can be written in its form of magnitude and direction. So over here ax is written as vector ax is written as ax into I vector and ay into j vector. Now what is this ax and ay? So ax and ay are nothing but magnitudes of vector ax and ay. And what about I and j? So I is a unit vector. We have already discussed unit vector. Its magnitude is 1 and direction is same as ax. So I is a unit vector which is directing along x-axis, and also in this case of ax, vector ax. Similarly, j is doing the same thing and it is directing along the y-axis and also vector ay. Okay. So vector I is directing along vector ax, j along ay. So we have differentiated a vector into two parts, magnitude and direction. Now what we can do is we can check this triangle over here that we have. Okay, and in this triangle what we can say is cos theta is ax upon a. We all know that cos theta is adjacent upon hypotenuse. So this side ax is nothing but the adjacent one and hypotenuse is a. So from this I can write ax is equal to a cos x. Similarly, sin theta can be written as ay upon y, right? So uh, opposite to this angle is this side. If I draw a vector over here, so this will be similar to our ay vector which is over here. Okay, so we got ay upon a, so this can be written as ay is equal to a sin theta. Now what we'll do is we will square and add these two terms. Okay, what we'll do is we will square and add 1 and 2. So when we square on the left hand side, what we have ax square and ay square, we have to add it. On the right hand side we got a square cos square theta and a square sin square theta. So we can take a square common, and what we are left with is sin square theta plus cos square theta. Please tell me what is sin square theta plus cos square theta. Yes, it is equal to 1. So what we are left with is ax square plus ay square is equal to a square, and from this what I can write is my vector a can be written in the form of ax square plus ay square. So this is the formula for finding the magnitude, for finding the magnitude of a vector. Let us see how to find the direction. Now to find the direction we need to find out what is angle theta. So for that we can write the formula tan theta is opposite upon adjacent. Opposite side is ay, adjacent side is ax. So theta can be written as tan inverse ay upon ax. So this is the formula method of finding the angle of at which the vector is inclined to the horizontal axis. Similarly, if you have a vector r, let us say, which is having three component rxi, ry along j and rz along k, then in that case the magnitude of r will be given by under root x component का square, y component का square and z component का square. So remember this method of finding the magnitudes of a vector. Let us try and solve a sum from here so that the concept is more clear to us. Let us say you have a vector A which is given as 3i plus 4j. Tell me what will be the magnitude of this. So magnitude of A will be given by root of x component means 3. Okay? Anything with I is nothing but your x component. Anything with j is your y component. Okay, there is no z component, so we'll go ahead with this. So how much is this? 9 plus 16, which is root of 25. So we got magnitude of A as 5 unit. Now if you want to find direction, you can find direction also. Direction will be theta is equal to tan inverse y component, which is 4, upon x component, which is 3. So this is the now you need to look at the logbook to find this answer. Okay, फिलहाल के लिए we'll keep it like this only. अच्छा, if you have two different vectors to be equal, then their components has to be equal. I'll repeat what I just said. If two vectors are equal, their components should also be equal. What do you mean by that? So let us say I have vector A which is axi plus bxj, sorry, axi plus ayj plus azk, and another vector B which is bxi plus byj plus bzk. Now for this vector A to be equal to B, their component should also be same. That means Ax should be equal to Bx, Ay should be equal to By, and Az should be equal to Bz. Right? Hope you all understood this. Let us say I have a vector A which is given by I plus 2j, and there is another vector B which is given by 2i plus j. दोनों का magnitude निकाल लेते हैं. Magnitude will be equal to root of x component is 1 का square, y component is 2 का square, which is nothing but root 5. And b के लिए similarly we'll have root of 2 square plus 1 square, which will be equal to root of 5. Now यहाँ पे दोनों का magnitude तो same है, but their components are not same. Ax is not equal to bx and ay is not equal to by. So they are, vector A is not equal to vector B. I hope you all understood this resolution of vectors. Please let me know if there is any query.